why would the performance of an agent degrade in any way? And why is that somehow different than classic system support? Like, I have my own opinion here, but I want to get everyone's, and then I'll tell you what's right. Um, but just, what's different? Why is this thing going to not perform the way it should over time, or what other factors are involved that are unusual or new?
Yeah,
Who wants to go?
I'll go first just so that because Stu's smarter than me, so I'll let him go second. So, the reason I don't like the term drift for this is I think there are very specific reasons that performance is perceived to change over time. I think you can have things like a new group of personas come in. That new group of personas, those new users who have a different perspective on the business, are going to ask a different set of questions. That's not necessarily a drift in behavior, it's just a different perspective that needs to be injected into the context of the agent.
One could argue if you're not close to all this, that you just didn't test it.
And I think Stu was talking about deterministic versus probabilistic as well. And I think, you when you have users interacting against a probabilistic system, you can test so much, but you still need to account for differences in human behavior. So I think there's the probabilistic versus deterministic, and also the human in the loop interjects with what's a good answer, what's a bad answer, and they need to be able to model, uh, update their context to handle those differences.
Okay. Joey, what's your take?
Well, again, I always try to bring it back to consumer sort of talk, right? And thinking about using LLMs in my everyday. And I think everybody's sat there and Fonzied the machine with a Chat GPT or a Claude when you're trying to get it to write a proposal, and it might take your words too literally, or there's something that maybe you gave it an example of, hey, I want you to do it like this, and it does it exactly like that, but it didn't take in the context of what you're trying to get it to do. And that's outside of the world of analytics, right? So you take a model that behaves like that and you put it to answer, enterprise analytics questions. And let's just say you have it on one single data set and you have it on maybe one market. If you're global enterprise, you're looking at your market. Maybe it's in the UK, or you're in the US, or you're in Brazil, but each individual market is going to ask questions differently, even on that same data set. Each language that they ask is going to behave a little bit differently from an interpretation perspective. And now that model is sitting there and it's been set up and configured on maybe one of these markets, maybe all of these markets, who knows, but it's trying to interpret your question and then pick the right tool to go and query a database. And that's a single database. Now you add in multiple databases, you put in disparate databases, you added more markets. Now go back to the beginning where we're just trying to get it to write a proposal in the right language using a single document, and it can't do it each time, right? So when you're working with tools like this, you have to have someone there that is observing it, is observing any feedback it gets, and you don't want that to be automated. And I think that's again where customers wonder, why do we need agent ops? Why can't it be self-learning? But if it learns from Brazil and goes and applies that globally in every single one of your markets, you've got a huge problem. And that's not going to lend itself well to a scalable enterprise solution without those agent ops sort of managers there to support this, and to continue just to continue scaling it and making it better.
Stu, I know I should turn to you, but I want to jump in on one thing. In sort of classic software customer success stories, there was the user, the buyer of the software, and there was the originator or software owner, sort of a two-party system. And that originator might be, that might be your organization within your own company that wrote and created something custom. You might be buying a SaaS service from some kind of vendor. And I think those relationships still exist, but there's a third party at the table here now, and that is the owner of the intelligence. And what we're creating with agents or intelligent applications in this sort of non-deterministic, probabilistic world we keep talking about is fundamentally some level of decision making. And that decision making has a certain variability to it. That's the probabilistic point. But there's a third party in this in this game now, and that's the owner of the large language model that is the intelligence that's inserted into whatever we're trying to do here. And they are the owner of that intelligence. And from time to time, they can make changes to that intelligence, and that will cause it tomorrow to react or to act differently, even with the same set of inputs, the same user questions or the same user usage or the same API relationship. Somebody else is at the table right now, and they might have, they didn't necessarily go from version 3 to version 4. They might have just corrected in some weights in the model under the covers, and that will create. That to me is sort of where drift comes from. They made a change. We weren't necessarily party to it. We, the creator of the solution, or the client, the customer of the solution, and things can change as a result of that. We have some conspiracy theories even about changes to models by large language model providers. We'll drift into conspiracy theories in a few minutes. And Nicole, she and the sort of the Kennedy assassination and what the large language model providers do, but they can change the solution. There's a third party at the table, and everybody needs to recognize that they're not in complete control here. Enormous value, enormous ROI, enormous potential, but there's more players at the table. Sorry, Stu, your turn here.
Yeah, no, I agree with everything everyone said. And I think we joke about Nicole and I having different opinions on drift. It is probably just what we define as drift. Fundamentally, I kind of think of drift as the system is becoming something different than you thought you deployed. So you tested it through a bunch of scenarios prior, and now maybe even rerun those same scenarios post deployment, and it's operating differently. Right now, that could be that it's operating differently just because of this non-probabilistic nature, or it could be that, well, 1 out of 100 times when I give this prompt, I'm going to get a weird answer, just based off of the statistical distribution of the types of answers I'll get. It could be something like that. It could be but it's more often, I think, from changes that are happening in the environment, right? So I think, which can also be changes under the hood by the model providers themselves, right? That OpenAI or Anthropic or Google or someone has made some sort of subtle change in the model. But I think of drift as actually the interesting thing here is a lot of what we talked about is the problems you have with what I call level A agents, right? In my mind, there's 3 levels of agents that you can have. And the first level is around using LLMs to automate a workflow. And and that's can still be very complex agents because you can be having multiple steps, but the steps are largely defined, and an LLM has a job to do at each start of the process or at each part of the workflow, but you've tried to engineer that workflow as much as you possibly can. Level 2 gets into more where the agent is more goal directed, meaning like, I need you to accomplish this goal, and the agent kind of decides how to accomplish the goal, right? And then level 3 is actually when you have multiple agents coordinating with each other inside of a system in order to accomplish goals. Everything we talked about is hard at that first level. The complexity rises even more as we go to the additional levels.